Thank you everyone for coming. This event is being put on by the MIS Club. And today we'll be talking about AI. I'm sure everyone has heard of like ChatGPT and a lot of Google, or they're doing Bard AI. There's a lot going on around it, but not too many people know what it is. And today we'll be discussing that and kind of what our future looks like in terms of how AI will change jobs and the economy. And today, as our guest speaker, is Graham Moorhead, who is an adjunct professor at Gonzaga teaching AI, and he has over 25 plus years of experience in the industry. So please welcome him.
Nice to meet everybody. And I want to demystify some of the strangeness that AI may seem to have for some of you. I do see at least one of my students out there, and I hope some of you in the future take one of my classes. I teach data science and machine learning, but today we're going to talk about the shape of thought, because artificial intelligence is just another kind of intelligence, but behind the scenes kind of has the same shape. Can a submarine swim? Raise your hands if you think you can. Raise your hands if you think you can't. No abstentions. It kind of depends how you define the word swim, right? Same thing for how you decide whether a machine can think. Can a machine think? Well, a submarine moves through the water, gets from one place to another. A machine that's a computer can do processing of information. Is that what thinking is? It's actually not all that interesting a question. The more important questions will come later, like this. Will AI take my job? Will AI take my life, like a Terminator? I mean, this is starting. 2020 was the first documented case of a drone taking out a target without a human operator in the loop. It found the target, chose to take it out, and killed someone without a human operator. That's chapter 1 of Terminator, right? What do you feel when you see this? You get an instant emotional reaction. You don't have to think about it. But if you were to solve this, you do have to think about it. You have to sit down. You have to go through steps. It's slower. The first one is faster. This is slower. System 1 is the part of your brain that does unconscious thinking, your instinct, how you feel when you see that picture, or how you would feel if you're in an alleyway and you sense danger. You don't have to go through steps. It's instant. System 2 takes effort. It's conscious. You go through steps. It is slow. Daniel Kahneman, seen here winning the Nobel Prize, came up with this way of thinking about different parts of the brain. And it applies to AI as well. AI type 1 is like your instinct. It's very quick. And it always takes the same number of computations. A neural network is like this. So for a neural network, you don't have more computations for a complex situation. It's always the same. Simple, you do this many computations. Complex, you do this many. It's always the same. Type 2 is more like your system 2. When you're doing a word problem or a math problem, you go through steps one at a time, and you think about each steps. AI can do both things. Now, type 1 is much more popular these days. Computers also have models. What is an AI model? What is a model of anything, right? What is a model airplane? It's smaller than the real thing. You can't fit inside it, but it has similarities. It acts like the thing you're modeling. It has 2 wings. Maybe it can fly. Maybe it has a remote control. A model should act like the thing you're modeling. Think about a model of a person walking. We used AI to teach something like this to walk. And at first it looked silly. It would just fall down and act all like a drunk person. After many, many generations, or maybe thousands of virtual years, it learned to walk very efficiently and walk like a human. But you can't give it all the freedom in the world. You have to give it constraints. It only has 2 legs, a torso, 2 arms, and a head. Can't give it more legs, even though that may help it walk faster. And the knee can only bend one way. You have to put constraints on how the model can act, so the model acts like the thing you're modeling. When they do give it more freedom, the AI can find all kinds of other ways to walk that involve, 4 legs and a head and who knows whatever else. I mean, if you let it do whatever it wants, maybe it rips one of its own arms off and throws it. It gets there faster, right? But it's not teaching you anything about human walking in that case. Topology and graph theory are 2 things we're going to talk about today. Topology is the mathematics of shapes and how things are connected. And if you look at a globe, we all know that a globe is a sphere. Our Earth is a sphere, but we like to use maps. So we make sacrifices. To turn the sphere into a 2-dimensional map, you have to cut it somewhere, you have to break it somewhere, or you get Greenland is the size of Africa. We all know that's not true. So you have to make sacrifices. What about the topology of the world of Pac-Man? Does he live on a sphere? Who thinks he lives on a sphere? I mean, you go off one side, you get back to the other, right? Who thinks he doesn't live on a sphere? What shape does he live on? But can he go up the top too? No? Yeah, you're right. If he could go up the top, imagine if he could. Would it be a sphere? Actually, it wouldn't be a sphere. It would be a donut. And there's this guy did a deep mathematical analysis of why, but you take the cylinder and you wrap it around and it becomes a donut. But it's slightly different from the sphere. But in both cases, if you go in a straight line, you eventually end up where you started. But this shows that there's some complexity in the way things are connected. Now, this is Königsberg, and Euler lived here, and he was the one who came up with graph theory. There was a popular game at the time. People would take a walk out in the afternoon, and they would try to walk across every bridge exactly once. You fail if you cross a bridge twice. And Euler was the one who figured out the answer. Who here thinks they can see a path where you cross all bridges just once on one continuous walk, I mean. Well, Euler proved it's impossible. And he did it with graph theory. People have been trying for years, but there will always be one bridge you have to cross twice to get to all of them. Now, instead of looking at it as in this way, he converted it to 4 dots or 4 nodes, you can think about it, or vertices, representing the 4 areas of land and the connections of the lines between them. Those are the bridges. Graph theory is this theory that describes how things are connected. Topology is similar, but it's more about these shapes. Like think about going from the globe to a flat map. You have to make sacrifices. You have to break it somewhere. Well, interestingly, you don't have to break a coffee cup to make it into a donut if you have it in clay form. The joke is that a topologist can't tell the difference between a donut and a coffee cup. Important feature here is they both have one hole. But this mathematics of what is connected and what is not connected, whether it's a globe or a donut or a virtual person, a model of a person, it's all important. Now, there's another kind of connections that could be temporal connections, time-based connections. Think about every vertical column being a state of the world. The kind of things that AI models, it models sometimes a vector. Who here knows what a vector is? Think about it as a coordinate in some space, like XYZ. That's a vector. But you could have hundreds of dimensions. Well, instead of numbers in our vector, let's just put black, white, and gray. And each vertical line is like the state of the world in some day or moment in time. So this is t equals 0, t equals 1, 2, 3. You get the point. There's a different state of the world in each day. Now, there's also rules for how these transform. These are the rules. This is our simple little world. And in a simple world, you can analyze things and learn from it. So this is one of those rules. You have some state of the world today, 1, 2, 3, and this determines what's going to happen to the middle square to the right, number 4. You can think about it as parent, 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 child. Now, what happens when we take this very simple set of rules and we apply them to two worlds? These are two worlds, world A and B. They're very similar. In fact, they're only different by 1 square. And at first, when you apply those rules, they're very similar still. And those are both gray because they both apply that same rule. See the white, black, black makes a gray in the middle? Apply that same rule, and they're both gray. Now, these worlds stay similar at first, but then they diverge completely. This is a little bit similar to the butterfly effect. How many of you heard of that? All right. So you see these worlds diverge completely. It turns out, because of this, it's very hard for type 1 models like neural networks to handle this. They can handle it in maybe a little restricted space. Like maybe you're going to predict up to 10 steps, no more. But if you want to go beyond, only type 2 models can do this. Type 2 are the slower, the more conscious, that part of your brain or that part of an AI. And this is the temporal connectedness of things. Now it relates to language. Think about what language is. It's a way to take a sequence and turn it into meaning. And the shape of what's going on in your head is what's important here. Think about your ancestors 100,000 years ago, trying not to get eaten by the tigers, right? That sentence, Calvin, behind that tree is a tiger. That is like a braid of information. Now it comes out of your mouth in a sequence because you can only say one word at a time, right? But what you're saying is something much more complicated. In fact, it's shaped like a tree. And we've known about this since the late 1800s, since the work of Lucien Tenier, a linguist. You have the root. The root of the tree is the head verb, and everything else comes off of that. And the ancestors of yours that were able to weave and unweave these trees and these braids, they were the ones who survived. They were the ones who are your ancestors. And at first, we probably just had 2-word combinations after we had 1-words. But those 2-word combinations, we know they're related because they're next to each other, right? Go home, blue sky. They're related because we said one right after the other. But what happens when you get a more complex situation like gave? Gave is connected to 3 things: a giver, a recipient, and a gift. There's no way to connect 3 things if you have a sequence, because you can only connect to the one in front and the one behind you. So what do? It breaks the rules of topology. Well, it's a little bit like going from the flat map to the globe. We understand that the rules of topology were broken, so we're fixing that. We reconstruct something tree-shaped in our heads when we hear that sentence. We do it with word order. That's in English. Other languages use other methods. They might use a different order, or they might use suffixes. And then word order doesn't matter in the same way. But we're all doing the same thing. We're all taking a sequence that is not tree shaped and turning it into a tree in our heads. Language is tree shaped, and the sequence is a surface phenomenon. But the topology of your thought, or the shape of your thought, is tree shaped. Now, GPT is not like that. Who here has used GPT? Wow, that's the most hands raised so far today. Hope you're not using it for homework, especially you. So GPT uses something called self-attention. A self-attention block was meant to solve a certain problem. In the old days, we had difficulty when the first word of a sentence had to agree with the last word. That's a long distance interaction. To solve that, they said, hey, what the heck, let's just connect all the words. So this is a self-attention block where the AI, to process or understand, in a sense, the word it's looking a little bit at all the other words to different degrees. And we tried that, called it a self-attention block. And it didn't work, so we did two of them for the same sentence. For every sentence, there will be two of these, right? And they're looking at different things in different ways, but they have the same topology. It's just a crosswise matrix. Well, it turns out that didn't work either. So then we tried 8 of them. That didn't work either. So then we said, let's take all 8, we'll put in a self-attention network, and we'll have another neural network to interpret those results. That didn't work either. So then we took all that, we called it an encoder, and we stacked them up, 8 of those and 8 decoders, which are slightly more complex. Once we got to this level, you can just imagine how many matrices there are all the way down. It finally started to work. We called it BERT, and it's basically a meat grinder for matrices. Who knows what the actual topology is behind the scenes? It's just all of these matrices, all these self-attention networks all the way down. And what you just saw there is actually a smaller version of BERT. So it'd be over here somewhere. We've just gotten bigger and bigger and bigger. You can just imagine how many matrices these are. It's a giant meat grinder of matrices. After a while, it'll work, but is it really working this way humans work? This is how much data GPT-3 was trained on. 1.1 million years. When my daughter was 3 years old, we could have a reasonable conversation. 3. She didn't need 1.1 million years. GPT-4, which some of you may have tried out, no one knows how much data they trained it on because they won't say, but it's somewhere north of 100 years, maybe even 1,000 times more than this. So between 100 and 1,000 times more than this. They're literally running out of internet to train it on. Noam Chomsky, one of the fathers of linguistics, said that if a system works just as well for impossible languages as for possible ones, it's not teaching you anything about language. Now, this goes back to the walking example. If you have something that models the way a human walks, it has constraints on it. The knee only bends one way. You have 2 legs, 2 arms, torso and a head, not any number of things. GPT is like those models that have all kinds of legs and they can throw their arms. They can do anything. They don't have the same interconnectedness. They don't have the same shape behind the scenes. So yes, they will do interesting things. GPT is a beautiful input-output machine. Give it text, it gives you text. Sometimes it seems like an intelligent being created that text, but it doesn't have the same shape behind the scenes. GPT is like that crazy walking model. That's why we get stuff like this. Someone asked ChatGPT, if 9 women work together, how fast can they make a baby? GPT doesn't understand the world. It said 1 month. So AI will not take your job, and it's not going to take your life yet. But a human using AI just might. These are tools. They make humans more efficient.